Let's talk about solving these trig equations over here. Okay, so let's try to solve each of these equations. I see this cosine 2 theta over here. Oh, let's solve it so that theta is between 0 and 2 pi. Okay, so we're not going to write every single solution. So I see the cosine 2 theta there, and right away that means that I'm going to need a trig identity. So we just talked about that trig identity. So I'm going to write this as a 1 plus cosine squared theta minus sine squared theta is equal to cosine of theta. Okay. Now, I don't like it when my sines and cosines are mixed up. So what I'm going to do is I'm going to replace this sine theta, sine squared theta. And how am I going to replace that sine squared theta? I know that sine squared theta plus cosine squared theta is equal to 1. So what this means is I can write sine squared theta is equal to 1 minus cosine squared theta. So let's write that in for that highlighted part there. This is going to be 1 plus cosine squared theta minus parentheses 1 minus cosine squared theta. And set that equal to cosine of theta. Okay. Now, I want to clean this up a little bit. So I'm going to do some distribution here. So this will be 1 plus cosine squared theta minus 1 plus cosine squared theta is equal to cosine theta. The 1 and the negative 1 cancel each other out. I have 2 cosine squared thetas. So this becomes 2 cosine squared theta equal to cosine theta. Okay. So I'm going to take a short detour here for a second. If I gave you something like x squared is equal to x, how many of you want to go cancel an x from this side and an x from this side and I get x equal to 1? How many of you want to do that? Oh, holy cow. Gary, I just saw your comment. Yes. When I write cosine 2 theta, that's the same thing as cosine parentheses 2 theta. Okay. So I guess I asked a rhetorical question. Students always try to do this, and this is a terrible idea. Instead of doing this, what you should do is you should move it to the other side, x squared minus x equal to 0. And then you should factor. So you get x times x minus 1 is equal to 0. So in reality, there's 2 roots, x equal to 0 and x equal to 1. But so many times in my career as a math instructor, I see students do this thing. And what happens is they end up losing a root. So you shouldn't do this. If you're solving, you should move it to the other side and factor. All right. So having said all that, guess what we're going to do for this one right here? We're going to say, all right, we're going to move it over. So this is going to be 2 cosine squared theta minus cosine theta equal to 0. And then we're going to have factor out a cosine theta. And then you got a 2 cosine theta minus 1 equal to 0. So what this gives us is this gives us two equations. The first equation is cosine of theta equal to 0, and the second equation is 2 cosine theta equaling minus 1 equal to 0. So let's answer this first one first. For what angles is the x value going to be equal to 0? Well, I could just picture it in my head. I pictured the unit circle in my head. The x value is going to be equal to 0 when that angle is pi over 2. And the x value is also going to be 0 when the angle is 3 pi over 2. So I think from here we get pi over 2 and 3 pi over 2. Right? So that's one answer, or one set of answers. What about for the second guy? For the second one, I'm saying cosine of theta is equal to 1/2, right? So I'm trying to, the way I do it is I try to visualize the x value being 1/2 in my head. Now, you don't have to visualize it because you have the unit circle right here. But the x value being 1/2 is kind of like this part right here. I want to know, what are those two angles that'll give us that? Well, one angle is pi over 3. And then the other angle is 5 pi over 3. So this is going to be pi over 3 and 5 pi over 3, like that. Let's take a 10-minute break, and let's continue this when we come back.
Hi, Professor. Could you please write up to the first pages?
How far?
The first pages. I just will like take a pictures.